In this video, I'll go over every single SAT math formula you need to know to get 800 on the math section. So let's get started. So the first thing I'm going to do is I'm just going to go over the reference sheet real quick. So the reference sheet gives you the area and circumference of a circle, the area formula for a rectangle and a triangle, the Pythagorean theorem, the special right triangle, so which already gives you the proportions for each side, as well as the volume for all of these shapes. So these are all the volumes you need to know for the SAT, and they give them to you, which makes it really easy. It also gives you here the degrees of arc in a circle, 360, the radians of arc in a circle, which is 2 pi, and the sum of the measures in degrees of angles of a triangle, which is 180. Make sure you read these ones because these are very important because it allows you to go from radians to degrees very easily. So now onto the equations you actually need to memorize. So here the first one is in surface area. The first surface area one you should memorize is a cube. A cube is just 6s squared, or s is one side length. So that means that it's just s squared, which is the area of one side, times 6 because there's 6 sides. For a rectangular prism, it's just length times width, length times height, and width times height, which each of these is just all the possible combinations, and then it's that times 2 because there's 2 of each side. For a cylinder, it's 2 pi r squared because there's 2 circles. There's 2 circles, one on the bottom, one on the top, and pi r squared is the area of a circle, and then 2 pi r h because 2 pi r is the circumference of a circle and h is the height, so that allows you to solve for it. The cone here, a cone is pi r squared, which once again is the area of a circle, which is the base of it, and then pi rl, which l is the slant height, which basically just gives you the surface area of the cone part. And make sure you have the slant height and not the regular height. So in order to go from like slant height to regular height, what you would do is you would just plug in like the Pythagorean theorem, which is up above in the reference sheet, which you would just plug in r squared plus h squared, and then that would give you l squared, which is the slant height. Just make sure you always in slant height because that is how you find the surface area and the volumes of shapes. So now for like the sphere, so a sphere is just 4 pi r squared, which pi r squared is the area of a circle, so it's just 4 times that. Now on to a rectangular pyramid, which rectangular pyramids are kind of a little tricky. It's length times width, which is just like the base pyramid, which is like a rectangle, and then it's length times the slant height 1 plus width times slant height 2. So make sure you get both. There's 2 different slant heights on a rectangular pyramid because it's a rectangle base, so make sure you solve for each one and multiply it by the correct number. And here it's not times 2 because there's 2 triangles, even though there's 2 triangles, because triangle you half the area of it, so you don't need to half it. You just multiplying by 2, so they cancel out, so you can just leave it like this. So now for more formulas, so the standard form is just ax squared plus bx plus c. That's just something you need to know because it's on every single SAT. So for sum of solutions, that's negative b over a, and product of solutions, that's c over a. You may think that you don't need to know these because you can just get the equation and then plug it in Desmos and get the answer, but sometimes they give it to you with letters in the equation instead of numbers, and you need to be able to find the sum of solutions to the product of solutions, so you need to plug into these equations because usually they'll give you like the product of the sum of solutions, and then that will allow you to solve for it much easier. So now onto like vertex formula. So usually sometimes they'll give you like the vertex of the equation, and the only way you can solve it is plugging into vertex formula, not into standard form. So what you would do here is you plug into this formula here, where h comma k is the vertex of the formula. So then here, if you're giving it in standard form right here and you're trying to get the vertex of it, what you can do is that the h value, which is the x value, is equal to negative b over 2a, which this b and then this a right here. And then if you do get that, you can plug that in to find k. So now on for trigonometry. So for trigonometry, you need to know SOHCAHTOA, which just means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Just remember these right here. Just memorize SOHCAHTOA, and if you know that, that will really help you in all trigonometry problems. So now for like angle relationships. So a triangle, like I said in the reference sheet, is equal to 180, all the angles inside of it. So that's very helpful for like when you're trying to figure out what the angles are, which sides correlate with each other. You can just know they add up to 180. So if you know 2 angles in it, you know the third one too. And then one trick you need to know for finding the sum of all interior angles of a polygon is that that's equal to 180 times n minus 2, where n is the number of sides. So for example, a triangle is 180, so it's 180 times n, which is equal to 3 because there's 3 sides on triangle, 3 minus 2, which is just 180 times 1, which is just equal to 180. So now here for like parallel lines cut by a transversal. So parallel lines like these. So these lines here, they'll never intersect, and the transversal is like something like this that goes through both of them. So here, now going over the different angle types you need to know. is like an alternate interior angle. So this would be like this angle right here and this angle right here, and they are alternating and interior angles, and they have the exact same angle measure. So now going on to the corresponding angles, they would be angles like this one right here and this one right here, where they correspond. They're both on the exact same side, and they have the same exact value. Now for co-interior angles, so these ones here are both on the interior, but they add up to like 180. So this one right here and this one right here, they would be examples of it. They both are on the same side, but they add up to 180, so they're supplementary angles, and they are not equal. So just make sure you know those relationships, and those are basically the basis for all all angle problems. So now on to like circles. So circle, looks like this. And here, so say for example like arc length and sector area, those are the two like equations you need to know. So essential to find the arc length, it's just essential angle over 360 times the circumference. So what that means is essential angle. So say for example in this circle right here, I'm going to draw it out right here, and this is a right angle, so it's 90 degrees. You would do 90 over 360 times the circumference, because all you're doing is the ratio that it's covering. So here it's covering 1/4 of the triangle, so it's 1/4 times the circumference. Same thing with sector area. Is here, once again, it's 90 degrees still in this example, so you do 90 over 360 and then times pi r squared, which is the area of a circle. And when you do this, then this would give you the sector area, the area of this small portion right here, because you're multiplying the fraction by the total. Now for percents. So percent change is very simple, very easy to memorize. All you need to do is it's just new minus old over old times 100, which is basically like the change over the original number times 100, because the 100 brings it to a percent. So for like direct variation here, it's just y equals kx. So basically saying that when this goes up too, and then here inverse relationship means like this goes down and this will go up right here. So you just need to know like what they look like, and you don't really need to memorize these too well, just know like the basic patterns of them. So now on to like mixtures and weighted averages. So weighted averages is something like this. So this would be a weighted average equation, and usually they'll give you like liters, concentration, but maybe some other stuff. In this scenario here, you're giving 5 liters and a 20% solution, so it'd be 5 times 0.2, and then here it gives you 10 liter and a 50% solution, so 10 times 0.5, and then it'll be over L1 plus L2, which is the liter, so 5 plus 10, and this here would equal 0.4. So that is the new percent solution, the new percent of the solution it is. So that basically just how you solve for it. And usually problems like this are very easy to point out and see, because they usually use like unusual SAT wording in it. And this also applies to other ones where they give you average speed or like combined cost per unit problems and stuff like that. Just make sure you understand this formula here and you're good to go. So now on to like lines and slope. So slope here is very important, because on almost like every single test. So slope here, so say I give you this line right here. To figure out the slope of it, you just take the point right here and like the point right here, and what you do here is just y2 minus y1 over x2 minus x1, which is just rise or run. So here, if I have like a point right here and this point right here, you would do like, say here is y1 and then x1 and then y1, and then here is x2 y2. See, you just do here y2, this y minus this y, or this x minus this x, and make sure that the 2's, they always correlate. So the ones in the front are together, the ones in the back are together. It doesn't matter which one's 2 or 1, just make sure that they are corresponding ones. For the slope-intercept form, it's just a slope, which you get right here from this equation, and then plus b, which is the y-intercept. So say this is the y-axis right here. It's a little crooked, but just say it's the y-axis, it's just right here where it intersects, that's the point you put there. So for point slope form, it's literally just a point in the slope. So here y1, x1, that's the point, and then m is the slope. For exponential growth and stuff like that, it's just literally just exponential growth will look like this, decay would look like this, and then growth means that there's a positive r. This one here would have a negative r, meaning that this one's decreasing and this one's increasing. Here you probably can plug the problems in Desmos most of the time. Just make sure you know basically like what it means to increase, what it means to decrease. For exponent rules, these ones here you probably can just plug into Desmos very easily and solve, so I'm not really going to go over those. And the final thing is Pythagorean theorem. This is given to you on the equation sheet, but it's very important, so I'm just going to go over it real quick. So the Pythagorean theorem, so say you have a right triangle like this, and it must be a right triangle. here, this is A, this is B, this is C. C is always the hypotenuse. If you have any two side lengths, you can figure out the other one. So just A squared plus B squared equals C squared. So you just solve for the missing side length all the time. So this is very useful and used a bunch of times. Now on to every Desmos shortcut you need to know. So here for system of equations, all you need to do is if you're giving two equations, so say 2x plus 3 and then negative 2x plus 10, wherever they intersect, that is the solution to the point. So here this is where they intersect, so that's the solution to the graph. So now for quadratic, so say you're giving one like this, 2x squared plus 3x minus 10. Here they intersect at x-axis at these 2 points, so those are the solutions to the equation. So if you want to know just how many solutions it is without knowing the specific ones, you can do this. You can use the discriminant, which is b squared minus 4ac, where it's just in the standard quadratic form, and then you just plug into here. And if it's a positive answer you get, then there's 2 real solutions. If it's equal to 0, there's 1 real solution, and if it's negative, there are no real solutions. So now for like mean, median, standard deviation, stuff like that. So say you're giving like a data set of like these numbers right here. I'm just going to put random numbers. So say this is your data set, and then you want to see what the mean is. Usually you have to add all these up and divide by the amount there is. But in Desmos, you can just type in mean and then A, and it gives me the mean, the average of the entire thing. Same thing for median. So if I were to plug in median, here the median, the one in the middle is 3. So I don't need to spend time doing that. If I want to find the standard deviation of it, I'll just write stdev, and then here it give me the standard deviation of it, which is very helpful for sometimes when they're giving you standard deviation problems where it's asking for like which one has the biggest standard deviation, and it might be hard to tell, so you just need to plug in Desmos just so you can get it right for sure. It also has like a distance formula where, say for example, I have these 2 points. So I'm like A equals to 2, 1, and then B equals to 4, 10. So these are my 2 points, and if I'm trying to find the distance between the 2 points, I can just write distance in Desmos and then A, B, and then this is how far away the points are from each other. Usually you have to do this crazy long formula to get to it, but now in Desmos you can just write distance in the 2 points and you'll get to the answer. So the exact same thing for midpoint. So I'm trying to find the middle of these 2 points. I just write midpoint and then A, B. And then just like this, you can always write like the points out. So here if I want to write midpoint, I could write 2, 1, and then comma between them, and then 4, 10. It's just like, say if you use the A or B equals, it just kind of makes it a lot faster if you're writing that multiple different times. And these particular things are very useful because say like on circles and stuff where you're trying to find the center, the radius and stuff like that, you can just use the distance to figure out the radius between distance between the 2 points, and then the midpoint formula to see the center of the circle. And one other thing you need to know is like GCF. So this is not, you don't use really often, but here just trying to find the greatest common factor between 2 numbers. Say if you're stuck, like say it's 70 and like 20. Here the greatest common factor is 10, so now I know the greatest common factor is 10, and I didn't have to think about it at all. So Desmos is very powerful, very useful for stuff like this. So if you found this video helpful, make sure to like and subscribe for more SAT prep, and check out my other videos where I go over stuff like this even more in depth.